This next one. So I'm going to take x minus 2 and multiply it times, oh, well, I changed it. It's all right. I'll just leave it. In fact, I'll just make up my own. How about that? There. These are both polynomials, right? And I'm multiplying them together. The multiplication is implied right there. And we call this a binomial, bi meaning 2. We call this a trinomial because there's 3 terms. So if you try and do a binomial with a trinomial, you cannot do FOIL. Okay? FOIL only works with 2 and 2. So let's follow the process I just said. You're going to start with the x, and you're going to pass that x through to all 3 terms of the trinomial. So let's do that. What do we get? X times x squared, x cubed, x times negative 5x, negative 5x squared, x times negative 4, negative 4x, right? We all good with that? Once you have exhausted the first one, meaning you've passed it through to all the terms, you move to the second term here and you pass it through. So I'm going to do these on the bottom because they're easier to see, like that. So negative 2 times x squared is negative 2x squared. Then what? Plus 10x, good. Careful with those signs. Plus 8. How many terms did I wind up getting here? At the end of this, how many terms are right here? In that multiplication, how many were in there? 6. How many did I start with here? 2 and 3. 2 times 3 is 6, right? That if this was a 3 and a 3, you would do this multiplication, you'd have 9 terms. If it was 7 terms and 8 terms, you would have 56 terms when you do the multiplication. Then you collect like things together. Do you understand the process? Okay. All right, let's combine these up. X cubed, how many x squareds? Minus 7. So negative 7x squared. Everyone's so shy. Plus 6x and plus 8. Good? I don't like to go off on tangents, but this one is math related. Can I erase? All right. I just want to try and show you something visually that sometimes helps people remember things. You know, sometimes you have to see something visually to have it stick. If I write here x plus 2 squared, we all understand that that means x plus 2 times x plus 2. And then if we FOILed that, we would do x squared plus 2x plus 4, which would give us x squared plus 4x plus 4, right? That's the whole FOIL and all that junk together, right? Okay. Now, I'm going to try and prove that this answer is true with a picture. I'll try and make it quick. Can we all agree that if I give you a rectangle, call this W and call this, let's say, L, that the area of that rectangle is L times W? Can we all agree on that? Length times width is area? Okay, I'm about to draw you a different rectangle down here. Here's what it's going to be. I'm going to start right here, which is like this bottom corner of the rectangle. I'm going to get out my measuring stick here. And the first thing I'm going to do is I'm just going to walk out a certain amount. Someone tell me when to stop. But let me get to at least here, okay? Ready? Someone tell me. Okay, right there. Okay, that where you told me to stop, I'm going to call that X. All right? And now I'm going to measure it again. I'm going to bring it over here. I'm going to draw it over here. Okay, that's X. Got it? Now I'm going to add to this X a little bit more. And I'm going to actually add 2. Now it could be 2 feet, 2 inches, 2 millimeters, 2 miles. It doesn't matter. But let's just call it 2 of something. Actually, I'll do 2 markers. How about that? So there's 1 marker. There's another marker. There. So this is 2 from here to here. Agreed? Yeah? I'm going to do that here also. So from here to here is one marker, here to here is another marker. So this distance is 2 from there to there. Y'all all with me? Okay, we're almost there. Now what I'd like to do is I'd like to ask you what the entire length of this side is from here to here. How long is that? What is it? X plus 2. Got it? How long is this side from here to here? X plus 2 also. So what is now the area of that entire square? X plus 2 times X plus 2. Do you all agree with that? The area of this entire square is X plus 2 times itself. Yes? That's the area. Now I'm going to break it up into smaller pieces. What is the area of this right here? X times x. That's x squared, right? What is the area of this one right here? So how long is it here? 2. How long is it here? 2. So the area of that square is 4. Is that the whole area? We're still missing this and this, aren't we? Okay, what's the area of this one? 2 times x. What's the area of this one? X times 2. Now if we add all these together, what do you get? X squared plus 4x plus 4. That's just a geometric reasoning of why this turns into this and that it does not turn into this, right? This would not be enough. All right. Word problem time. These are more like geometric word problems. I'm going to look at number 2. Hey, before I do 2, do you know what the perimeter of an object is? The perimeter is the distance around the object. So like on number 1, it says write a polynomial that represents, let me just do this one. Okay, they give me some triangle. They tell me that this side is 3x squared minus 4x plus 9. They tell me that this side is 2x squared plus 4x minus 10. They tell me this side is 5x plus 3. And they say, write a polynomial that represents the perimeter of this figure. So that means all I need to do is add up these sides. This plus this plus this. So you're going to put this plus this one, collect all your like terms together, get the answer. Do I need to show that, or do you think you can handle it? Show it or no? No? Okay. All right, look at number 2. 2 is more interesting. They give you a square. Little more interesting, not too much more, but they tell you this is 2x minus 5, 2x minus 5. Then they have this square out here. And they want to know, I believe, find a polynomial that represents the area of the shaded figure. And there's one additional piece of information in there that's in the wording that's not on the picture. And what is it? The dimensions of the white square are x by x. So this is x by x. X here, x here. So what's the area of just this black part? Tell me in words what it would be. Even more general, just like in terms of like talking to another human, not without the x's. Just what's the area of this black one, black part?
The big area of the white.
Okay, good.
The area of the white part.
The area of the big square, take away the area of the small square, right? So what's the area of the big square? 2x minus 5 squared would give you the area of the entire thing. Subtract from that the area of this one, which is x squared. Right? Now this is a polynomial, but I actually want to do more work on this. I want to square this right now. And then I'm going to collect everything together. So when I square that, you realize I have to do this next to itself, right? Why don't you try that on your own? Expand that out. And then subtract x squared and see if you can get to the answer. If you get an answer, show your hand real quick. All right, good, good. Does it match mine? Okay. Just have to be careful on this multiplication here. Make sure you're getting these numbers and combining those two together and then subtracting the x squared off here. All right, we have another topic here. And then after this topic, do y'all want to do a break or just go through? Y'all like a little 5-minute break in the middle maybe? Go out, walk around or something? We'll try it this time. We'll do a little break right after the next section. This is going to be pretty short. All right, there's this third F word that you love. This one actually might be your favorite. Factoring. Factoring is the Achilles heel of many, many algebra students. Even my calculus students, their biggest weakness is factoring. And there are all types of factoring. The only thing I want to reference right now is what's called factoring using GCF, which stands for greatest common factor. And this method of factoring is by far the easiest, and it's the one we always try first. And let's see it in action. I want us to factor the following, all right? Factor 6y squared, I'm going to change the problem up, minus 18y. So factoring is actually the undoing of distribution. You know how we were taking problems where we had like a 2 and then parentheses and we were passing the 2 through? Factoring is the backwards of that. It's taking whatever we would have here and pulling the 2 back out. But we can do it with anything. Whatever appears, whatever factors appear in both terms can be factored out. So you're trying to find the greatest factor they both have in common. So I always like to start with the numbers. What is the biggest number that is a factor of both 6 and 18? 6, right? 6 goes into both, so you can factor a 6 out. And then you look at the y squared and the y, and you say, what is the greatest number of factors of y that they both have? Just one y, right? Just one. So we can pull one y out, one factor of y. Then we put a set of parentheses, and we're going to put a binomial in here. And the idea is that when I multiply this back through, I should get back this. So if you remove a 6 and a y from here, what's left? Just one factor of y. And if I were to factor out a 6 from here, what would still be left? A negative 3, a minus 3. And how about y's? No, because I already pulled one factor of y out, so just 3 would work. The good thing about factoring GCF is that you can always check your answer by just distributing back through, and you should get back this. Now there's different ways to teach GCF. I'm just going off the assumption you've seen it before, and it's just kind of rehashing the old stuff here. What about this one? 3x squared y plus x squared y. Let's do one more thing in here. Let's throw a z in there. 3x squared yz plus x squared y. Well, how about numbers? In terms of numbers, is there a greatest common factor we can pull out of both of these? We have a 3 here and a 1 over here, right? So there's no common factor, number-wise? What's that? This would have to have a 3 in it, or a factor of 3. It would have to be a 3 or a 6 or an 18 or something like that, right? So there's no common number I can pull out of both. Let's look at the x's. X squared, that's a factor of both, right? So I can pull out an x squared. How about y's? A y and a y, right? So I can have one of those. How about z's? I don't have a z here. I'm sorry, I don't have a z here. I do have one here, so I can't pull that z out. So I'm done with looking at everything, and in here I should have a what when I'm done here? Two things, right? 2 things. So a binomial. So what am I missing here? A 3 and a z would get me back to this, right? So 3z here. And then what about this one? All I have to do is multiply that by 1, right? So the mistake I see is that students will just leave it like this. But you can't. You have to put plus 1. Because you must get that distribution to occur and create 2 terms. Okay, let's look at one more. Why don't you try this one? Try this one on your own first, and then I'll come through and we'll talk through it. I'll give you one hint. You're going to have a big set of parentheses. And there will be 3 things in here when you're done. If you need a hand, raise your hand and I'll come by and help you out. I'm going to pass around the sign-in sheet. We had perfect attendance on the first day. Amazing. Who's there? Any show of hands here? Okay. No? Can I see what you got? 5 times 30. Yeah, double check that. Double check that. Close. Is there a number that goes into all of these? You got something? All right. I'm going to put the answer up here, but I'm going to have you all work through it with me. I think that's right, yeah. Okay, as far as a method is concerned, I like to always just look at the numbers first. What number goes into 25, negative 65, and negative 80? Well, they're all multiples of 5, so I could start with that, right? And after I pull out a 5 and I look at my answer, if I recognize, like, oh, wait, they all have a 2, I could do that later. I'll start with the 5. So 5 goes into 25. Well, let me just put the 5. I'll deal with what the numbers are in a second. How about x's? What's the common number of factors I have of x? X squared, right? That's the most that all of them have. And then y's, y to the third, y cubed. Okay, everyone okay with that part? All right, so think about, what do you multiply 5 by to get 25? 5. What would I need to multiply x squared by to get x cubed? X. What would I have to multiply y cubed by to get y to the fourth? Y. So that's my first term in there. Now, what do I have to multiply 5 by to get negative 65? 13, right? But I'll need it to be minus 13. How about x's? Do I need to multiply by any x's? No? How about y's? Yes? Y squared? Anything else on that one? We're okay? How about, what do you multiply by 5 by to get negative 80? Negative 16. And then x to the fourth, I'm going to have to put in x squared, and y to the third I already have, so just leave it. That should be it. Okay, we're going to take, let's try a 5-minute break. I don't know how well that's going to work. It's 2:01 on my watch. Be back at 2:06. Yes?
So, could you technically, instead of putting a 5, could you just leave it blank and imply a 1? And just put 25, 65, 80.
Leave those in there? You could, but that would not be considered to be completely factored. That would not be factored. Yeah. Did everybody sign in?
He's good.
He didn't sign in? He left before he signed in? Okay. All right, well, that was 5 minutes. That didn't seem like enough, but y'all ready? Okay, we're going to get through percents and proportions. So percents are something that we actually see a lot in the real world. You know, we hear it on the news and things like that. So it's just to make sure we have some general understanding of how percents work, how to translate words into percent problems. So when you see something like X percent, all this means is X out of 100. So when we say 13%, what we mean is if there were 100 of these things, we're talking about 13 of 100. So 13% of people love iPhones. That's probably a low percent, but that means if there were 100 people, 13 out of 100 would love iPhones, right? But that's not really realistic when you look at something like a classroom. Oh, we thought you left.
Sorry, I did call someone.
Here we go.
Thank you.
Yeah. Because if I said 13% of this class, there's not 100 in here, right? But 13% still makes sense to talk about, right? So what is 13% of this class, right? What is it? Well, we're going to answer that in a second. But in general, when we see a percentage, it's always out of 100. Keep in mind, 50% would mean 50 out of 100, which is half, right? We reduce the fraction. And as a decimal, that's 0.15, or 0.5. If you say 100%, that means 100 out of 100, which if you turn that into a decimal, it's 1 or 1.0. Some key words that we need to be aware of when we're doing these word problems is that most of the time when you see the word of in a problem, that implies multiplication. And anytime you see the word is, it usually means there's an equal sign, or equality is there. Remember that when you convert, when you're converting, if you ever want to convert from a decimal to a percentage, you're going to move the decimal 2 places to the right. So let me see here. Here's a decimal, right? 0.13. If I take that decimal and convert it to a percent, I move this 2 places to the right, and it becomes a 13%. If I want to go the other way, I want to go from a percentage to a decimal, what I do is I take the decimal point, which is actually not written here, it's right there. There's a decimal, there's a decimal. And I'd move it 2 places to the left. 1, 2, that becomes 0.5. But the percentage goes away. With all that in mind, let's do some of these problems. What is, or what percent of 200 is 21? What percent of 200 is 21? Anybody have an idea of how to do this? Pardon me? Is over of. I don't, maybe, I don't know.
21 over 200.
21 over 200. Okay, so that's just kind of reading it and thinking, that's what I'm going to wind up doing as far as the math, right? What I want us to do and be comfortable with is turning this into a linear equation. Right? That's what we were just looking at linear equations, weren't we? This is a linear equation in words. You were asked to find something, right? What percent? This is what we want to try and figure out, yes? That's the x. X of, I said in these problems, usually represents multiplication. So this means x times, what? 200 is equals, right? Is equality, 21. That makes sense as far as translating it directly from words into an equation. So I'm going to rewrite this. X times 200 is the same as 200x equals 21. And I'm going to break out my calculator because this is going to be a decimal. All right, what do I do now if I'm trying to solve for x? Divide both sides by 200. And I'm going to, they say what percent, right? So the final answer needs to be with the little percent symbol. So on my calculator, I'm doing 21 divided by 200. And I'm getting x is 0.105. Anyone else get that? Yes? That's the percent, but it's not written as a percent, it's written as a decimal. How do we convert a decimal to a percentage? Move decimal 2 places to the right. So I'm going to say that x is 2 places to the right, 10.5%. Now, it's always a good idea to go back and replace your answer and read the problem and see if it makes sense. 10.5% is what we got, right? 10.5% of 200 is 21. Does that make sense to you? What would 50% of 200 be? It would be 100, right? What would 25% of 200 be? 50. So you can try and like rationalize your answer like mentally. It doesn't make sense that 10% of 200 would be 21. Now, I heard someone, I'm not going to call anyone out here, but maybe I didn't hear this. I thought I heard someone say, for this problem, you just do this, 200 divided by 21. Let's say that you didn't try to set up the equation. You just thought that's what it must be, 200 divided by 21. And then you would, 200 divided by 21. You would have got 9.52. I'm not quite sure if what you would do with that, if you would convert it to a percentage. But if you did, you would go, what, 2 places this way? So 952%. So would that make sense as an answer? 952% of 200 is 21. No. It would have to be bigger than 200, wouldn't it? So, all right, let's try another one. %, of a number is 19.5. Calculate that number. All right, so we're going to have some fun here. We're going to go around one table at a time. I'll take a volunteer, okay? So only, and you can talk to each other if you want, all right? Only one person from this table, or one group of people from this table, can tell me what the equation of this is going to be. So whoever volunteers, and if you could, just tell us who you are. Tell us a little bit about your history. No, I'm just kidding. Just your name. Come on, who's going to be brave? Wanna do it? What's your name, sir?
Caesar.
Caesar? Okay. I just have to see names. In fact, I'm real bad with names. Okay, Caesar. Go for it.
Make the 10% to decimal.
Okay, you want to change this to a decimal. That is a key part of these problems. If you're going to go to an equation, all percentages need to go to decimals. So very good. 0.15. Okay, that's right, because I moved it 2 places to the left. And I don't have to put the 0 there, but a lot of people do just so that you can see the dot. Sometimes you forget the dots there. All right, we'll keep going.
And I'm going to multiply it by the 19.5.
By 19.5.
Yeah.
Keep going, or are you done?
I'm done.
You're done? Okay, so Caesar, do you see an equation? You didn't create an equation, right? So where is the equal sign in that problem? I'm sticking with Caesar. Think about the key words.
Oh, okay.
Right?
So the is the equal sign.
That's right. This is the equal sign. So let me try this again. Let me just put the 19.5 out here. And the is the equal sign. So we have equation now. We're missing the linear part. Where's the x?
Of a number.
Of a number, right? So of a number is your times x. What do y'all think? That's it right there. That's it. We have the equation. 0.15x equals 19.5. So I'll just clean it up. 0.15x. Thank you, Caesar, for being brave. So the goal is to try now to solve this equation for x, which means you need to remove this 0.15 that's in front. How do you do that? Divide by it, right? Not subtract, because that's multiplication, right? So I'm going to divide both sides at this point by 0.15. Divide by 0.15 and get my calculator out. $130. X is 130. All right. Good? Let's just check it. I mean, what I mean by that is of a number, I'm going to kind of say of, what's the number, 130? 15% of 130 is 19.5. Is that reasonable to you? Do you know what 10% of 130 would be? 10%? 13? See, I think we all have some level of comfort with percents, right? If I say 50% of something, you always think half, right? So if I said 50% of 130, you'd be thinking somewhere, what, 65? So our answer here should be less than 65, right? Because we're 15%. The thing is, you don't want to get something crazy here like 15% of 2 is 19.5. Wouldn't that be kind of absurd to have that? So that's why it's good to just go back and kind of plug it in. Make sure you don't have some crazy statement. That means something went wrong. All right, next table. Back corner. And the problem, let me pick the hardest one I can find. I'm kidding. 25 is 40% of what? All right. Who's up over there? Go ahead. What's your name? Amber? Amber, okay. All right. 25 equals 0.4 times x. That's it. Good. I'm not going to solve it. I'm going to leave it to you. Let's move to the next table, next problem. What would you do? Divide both sides by 0.4? Okay. What is 35% of 200? Back table. Dun, 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 dun. I should get the camera, take the camera off and just go like from table to table. That would be kind of cool. All right, what's your name? Caesar, Ember, and Bethany. Okay, Bethany. X, so the what is your x? Equals? Okay. Okay. Now, Bethany, when you're working with the equations with percents, you never want to have a percent in the problem. You always want to convert it to decimal. So how would you convert that 35% to a decimal? Good. Okay, so this is going to be 0.35 times 200. Someone just tell me what that is real quick. What is it? 70? So 70 is 35% of 200. That seems reasonable. $35 is what percent of 200? We're going here.
Okay.
You can do it? Who are you?
Bianca.
Bianca. Okay. Caesar, Ember, Bianca, Bethany. Yes? Bianca. Okay, Bianca.
Okay, it's 35
35
equals
equals
x
x
percent times 200.
times 200. So I think you might, Bianca, you might be wondering, should you put the percent symbol here, right? Or just leave it as x? Because it says what percent, right? We're going to treat what percent as the x. And we're going to realize that our final answer needs to go back to a percentage. Does everyone see that? So divide both sides by 200, right, to get x by itself. What do you get when you divide by 200? 0.175. Okay? You all see that? Pardon me? Yeah, so now when we go back and we say, all right, what's the answer? Look at what we wanted. 35 is what percent? Well, that's not a percent, so convert it to a percent. This will be 17.5% equals x. What do y'all think? This okay? Who's up? Which table wants this one?
I can do it.
You want to do it? Okay.
Is it 35
Yep, 35.
equals?
Okay, you want me to just write it? Everyone has it. It says 35 is 15% of what value? 35 is 15% of what value? So you want me to write what?
35 equals 0.15x.
Yep. That's it. And then divide through by 0.15, and you would get whatever it is. Okay, those are all easy. So your table gets the fun one, all right? Oh, wait, what was your name? Sorry.
Oh, Dijon said we call him DJ.
DJ?
Yeah.
That is a lot easier, but I'll still forget. Okay. DJ, Bianca, Bethany, Ember, and Caesar. Okay, does everyone have the problem about the Northwest Vista transfer students in front of them? I do not want to write this on the board. Let's see if we have the same numbers. If you don't have this with you, make sure you bring it, and if not, read off your neighbors. 30% of all students at Northwest Vista College transfer to UTSA. Of these transfer students, 12% are going into biology. If there are 15,435 students at Northwest Vista College, how many will transfer to UTSA and major in biology? So now we're getting to something that's has a little more meat on the bones, right? Everyone has that problem, sees it, understands it? I'm open to some approaches here. I'd like to ask this table what they'd like to do, but I'll give you a hint. It's going to be very difficult. Just write an equation down straight from this. So any sort of approach? What's your approach? Who? Go ahead. What's your name?
Sean,
Sean.
is it a two-step problem?
You can treat it as a two-step problem. How would you do that?
Figure out what 30% of 15,435 is, and then from that, figure out what 12% is.
Okay, good. I like that approach. So the way that Sean is looking at it is you've got everyone at Northwest Vista College, right? And you've got some people who are going to go over here to UTSA and major in biology, right? I'm trying to draw this in pictures. And so you know that there are 15,435 students over here, right? 30% of those students are going to transfer to UTSA. So 30% of this group.
30 times 15.
Yes, hold on. Let me do this. 30% of these students, right, are going to go to UTSA. They're going to go over here, right? They're going to go over to this UTSA. But then of that group, only what? 12%. So here's that group written down over here. There's that group, however many there are. And then you're going to take 12% of them and go into biology. So this is a two-stage problem. You could do it as a two-stage problem, or you could do it all at once. But I think two stages is better. So first, let's figure out what 30% of this number is, right? So I'm going to ask myself that question. What is 30% of 15,435? Right. So that's my first thing, right? And then I create an equation out of that, and I solve for it. And can I trust that you could write that as an equation now and come up with the answer? And what does it come out to be?
4,630.
4,630. So there are 4,630 students. That,
If it's 0.5, you just go ahead and round up to 4,000.
is it a decimal? We'll just cut that person in half, yeah. So we'll just go 4,630. That's how many are going to transfer out to UTSA. Of that group, only 12% are going to go into biology. So now I want to know, someone tell me in words here. Good. What is 12% of 4,630, right? That's what we're asking now. Pardon me? So you could solve this equation now. X equals 0.12 times this. And what's the answer? 555? 555. Or 0.6, yeah, close enough. Now, for those of you who want to push the envelope a little bit, you could have done it this way. You're going to take 30% of 15,435, right? That's 30% of the total population. And then you're going to take 12% of that, right? So you can just do 0.12 times that. Oh, 0.12. 12%, 0.12. That's how you can do it all at one time. All right, let's look at the next problem. Assume there are 425 statistics students at Northwest Vista College. So I'm going to start using these little blobs to draw pictures to try and help me see what's going on here. There are 400. Wait, did I skip a problem? I did. Oops, number 8. 30% of all students at Northwest Vista transfer to UTSA. We kind of knew that already? Oh, it's the same problem.
No, it's a little different.
Oh, yeah, okay. Of these transfer students, 12 are going to major in biology. What percent of NV students are going to major in biology at UTSA? What percent? Yeah, but they're not telling us how many students, they're not asking us how many students are going to major in biology. They're saying what percent.
So 12% of 30% of the students.
That's right. It's 12% of 30%. It's kind of like saying if half of the students from at Northwest Vista go to UTSA and half of those major in biology, so here's all the students, right, at Northwest Vista. Let's say half of them are going to go to UTSA. And let's say half of them are going to go into biology at UTSA. Then what percentage of the whole is that? It's 25%, right? How would you have got that from, right, 50% are going to go to UTSA, and then 50% are going to major in biology. How do you get to 25% from that? It's half of a half, isn't it? It's if this is half and this is half, what happens if you multiply these two together? Get 1/4. You get a quarter. So the end of the day story here is that what you need to do for this problem is you need to take 0.12 and multiply it times 0.30, which is, what is that? 36.036. Okay, and convert that to a percentage, which would be 3.6%. Does that make sense? This one's a little trickier. See, what we had before was we had 30% of a population, right? 15,000 or whatever, and then we took 12% of that. Here, we're not saying how much the population was. We were saying the population, instead of being 15,000 here, whatever, 15,000, was just the whole population. We could call it one population. So what we're going to have is 3.6% of the whole population will be there in biology at UTSA. All right, let's try, oh wow, we only have a couple of minutes, huh? Let's see if we can knock these last two out. Assume there are 425 statistics students at Northwest Vista. Stats, Northwest Vista, 425 students. Okay, in that group, of which 35% plan to go to nursing school. Okay, so of this group, 35% of that group is going to go to nursing. I'm drawing pictures to try and help me see what's going on. If all the students who plan to attend nursing school are enrolled in statistics this semester, what percent of the 15,000 students plans to attend nursing school? What? So
you're taking 35% of 425, taking that total and comparing it to the total number of students. Wait, what percent is?
okay, yes. What is your approach there? Sean, right?
I thought, doesn't it say that the nursing school students are part of the 425? And so don't you have to just take 425 out of 15,435?
Okay, this is where things get tricky, is interpretation of the problem, correct interpretation of the problem. So let's go slow. We have 5 minutes. Assume that there are 425 students. So we agree these students, 425, are at Northwest Vista and they're in stats. They belong to a bigger group of students at Northwest Vista, right? That include 15,435 students, right? That's a subset of that group. 35% of this group plans to attend nursing school. It says, if all of the students who plan to attend nursing school are enrolled in statistics this semester, that means out of everybody in the school, if all of the students who are going into into nursing school are in statistics, then what percent of this 15,000 plans to go to nursing school? So Here's the wording is very subtle because this group that I'm shading in here, they plan on going to nursing school, don't they? But there might be some other people over here that want to go to nursing school too. And they're asking you to figure out the percent of the whole. That's why they have to say in this statement, if all of the students who plan to go to nursing school are in statistics, then that means this group does not exist. And this is the only group of students who are in statistics going to nursing school. Understand? That's why that sentence has to be there. So what percent of the entire population is going to go to nursing school? So how many students are in here? 35% of that, right? So what is 35% of 425?
148.
What did you get?
148.
148? So there are 148 students, not 148 and a half or anything? Was it a decimal? It's fine. We'll just say 148. Good enough. So there are about 148 students that are in stats planning to go to nursing school. And since these are all of the students planning to go to nursing school, then the percentage of the population, we're saying what percent how do we write it? What?
Of the 15,435 planning to attend nursing school.
What is it?
148.
What percent of this plans to attend nursing school, right? So you want to know, I'm asking you to give me the sentence that would use this information to get our final answer.
0.148 equals 15,435.
0.148?
First divide.
They're asking for a percentage, right? What percent of? I think we're getting close. How about this? 148 is what percent of 15,435? Is that right? Does that make sense? We want to know 148 students is what percentage of the original population?